Welcome back. In front of us, we have a question that reads, a car at rest is given an initial uniform acceleration of 1.8 meters per second square for 40 seconds, after which it decelerates at 1.2 meters per second square for the next 20 seconds. The car maintains the speed attained for 70 seconds, after which it is brought to rest in 30 seconds. Question A. Draw a velocity time graph of the motion using the information given above. Question B. Using the graph, calculate 1. The maximum speed attained during the motion. 2. The total distance traveled for the entire motion. 3. The average speed traveled for the entire motion. 4. The total distance traveled during the first minute of the motion. 5. The average speed during the same time interval as in question 4 above. 6. The retardation that brought the car to rest. So if we should analyze this problem, the car is initially at rest. It is given an acceleration of 1.8 meters per second squared, which lasted for 40 seconds, after which the car decelerates at 1.2 meters per second squared for the next 20 seconds to attain a constant speed. So it then maintains that speed for 70 seconds, after which it is brought to rest in 30 seconds. By analyzing this problem, it tells us that the car has 4 phases of motion. We have acceleration, then deceleration, then maintaining of a constant speed, and then a retardation to rest. So this is how we are going to draw the velocity time graph. So the first thing we will do is to move on and draw the velocity time graph as instructed by question A. Question A, the velocity time graph. What we need to do is to first draw the time on the x-axis, that is measured in seconds, and then we draw the velocity on the y-axis. So that is the velocity in meters per seconds on the y-axis. So the first information we are given is that the car starts moving from rest and it accelerated. So when a car starts moving from rest, the motion will be from the origin 0, that is at this point. So from this point, it accelerated uniformly. So we have a line that indicates the acceleration, and the duration for the acceleration was 40 seconds. That is 40 seconds. The acceleration was at 1.8 meters per second squared. Okay, so that is acceleration is equal to 1.8 meters per second squared. So after the acceleration, the car decelerated for 20 seconds. And this is how we're going to indicate that. That's the deceleration of the car, which lasted for 20 seconds. So which means from the origin here up to this point, the car has traveled 60 seconds. By adding it to the 40, we will have 60 seconds here. So the car decelerated from this point here way down to this point to attain a constant speed or velocity. So this is where the constant speed or velocity is attained. Okay? The magnitude of the deceleration was at 1.2 meters per second squared. The car decelerated from this point here to this point here in order to attain a constant speed or velocity. So this is the point where the constant speed is attained. The car maintains that constant speed for 70 seconds. So we're going to indicate that with a horizontal line. So it maintains a constant speed for 70 seconds. If we should add that to the 60 seconds, that will be 130 seconds. So after which the car decelerated to rest in 30 seconds. So if we add that to 130, that will be 160 seconds. So which means the total time travel for this motion is 160 seconds. To give a quick summary, the car starts moving from rest here and it accelerated at 1.8 meters per second square to attain a velocity at this point. That is the final velocity during the first phase of the motion. So after that, the car decelerated uniformly at 1.2 meters per second square to attain a constant velocity here. It then moves with that constant velocity for 70 seconds, after which it decelerated to rest in 30 seconds. So by analyzing the velocity time graph, it tells us that we need to know two final velocities. One of them is the final velocity that is attained at this point. So since it is the final velocity of the first phase of the motion, we can call that v1. Then we need to know the final velocity at the end of the second phase of the motion, which is at this point. So we can call that v2. Before going to the question, we need to know v1 and v2 so that we can complete the velocity time graph, and after which we can calculate the distance or the average speeds and so on. So this is the origin 0 for where both time and velocity is 0. Now to find v1, if I use v is equal to u plus at, because I am considering the first phase of the motion, I will say v1 is equal to u1 plus a1 multiplied by t1. So v1 is equal to what is the initial velocity for the first phase of the motion. This is the initial velocity for the first phase of the motion because the body starts from rest. And this is the final velocity for the first phase of the motion. So u1 is 0 plus the acceleration for the first phase of the motion is 1.8 meters per second squared multiplied by the time duration for the first phase of the motion is 40 seconds. So V1 is equal to 1.8 times 40, that is 72 meters per second. So in the place of V1, I can write 72 meters per second. Okay? Then after that, we need to find V2. So this is the final velocity at the first phase of the motion, but you have to remember that it is going to be the initial velocity for the second phase of the motion, right? Because the final velocity for the initial phase of the motion will serve as the initial velocity for the next phase of the motion. So as you can see, the body starts decelerating from this velocity, that is 72 meters per second, during the second phase of the motion to reach its final velocity here, which is V2. So we are going to use 72 meters per second as the initial velocity for the second phase of the motion. Now, using V is equal to U plus AT, we can say V2 is equal to U2 plus A2 multiplied by T2. So that is V2 is equal to U2, that is the initial velocity for the second phase of the motion. We said that is going to be this point, so that is 72 meters per second. We're going to have 72 plus the acceleration at the second phase of the motion is 1.2 meters per second squared. But be careful, since it is a deceleration, you have to allocate a negative sign to it. So we're going to have negative 1.2, then multiply by the time interval for the second phase of the motion, that is from here to here, is 20 seconds. So V2 is equal to 72 plus minus 1.2 times 20, that will be 48 meters per second. Okay, so which means the final velocity for the second phase of the motion is 48 meters per second. So we can indicate that on our velocity time graph. Okay, so V2 is 48 meters per second. So that is the complete velocity time graph. You have to indicate the velocities and the times that we have. Moving on to question B, it asks us to use the graph to calculate the maximum speed attained during the motion. So looking at the graph, we can clearly state that the highest speed or the maximum speed attained during the motion was 72 meters per second. Okay. So B1, the maximum speed attained during the motion is 72 meters per second. Okay. Question B2 is asking us to calculate the total distance traveled for the entire motion. 2, the total distance traveled for the entire motion. So if we should try to bring the velocity time graph, we can indicate the phases here as S1, S2, S3, and S4. So we're going to use the areas under the graph to find the distance. Now, if we consider S1, it is a triangle, as you can see. So we're going to use the area of a triangle to find the distance. So if I can just draw the shape again, for S1, we have something like this. Okay, the time is 40 seconds and the velocity is 72 meters per second. So this will be 72 and this is S1. So to find S1, we use the area of a triangle, which is half base height. So that is going to be half, the base is 40, the height is 72. Doing that math, we will have 1,440 meters as the distance for S1. To consider S2, if you look at it, it is a trapezium. Okay, so we're going to use the area of a trapezium to find S2. So if I should draw the shape again, this is how it looks like. So going back to the diagram, the time interval is 20 seconds. This side is 48 meters per second. This side is 72 meters per second. 20, 48, 72. So that is S2. Now to find the area of a trapezium is half A plus BH, where we can choose this as A, this as B, and this will be the height. So A and B are the two parallel sides, okay, of the trapezium. That is S2 is equal to half 48 plus 72 multiplied by 20. And if you do that math, you get 1,200 meters. Moving on, if we want to find S3, the shape of S3 is a rectangle. Okay, so the time is 70 seconds. The velocity is 48 meters per second. So let's try to draw that. We have 70 here. We have 48 here. That is S3. And S3 is a rectangle. So the area of a rectangle is length times the height. So that will be 70 times 48. And 70 times 48 is 3,360 meters. Finally, for S4, if you look at it, it is a triangle. So we're going to use the area of a triangle to find S4. The time there is 30 seconds. The velocity is 48. So if we should draw the diagram for that, we have something like this. The time is 30 seconds. And we have 48 here. The velocity. So that is S4. To find the area for S4, that is half the base times the height. So that is half 30 times 48. And when you do that math, you have 720 meters. So to calculate the total distance, that is S total, that will be S1 plus S2 plus S3 plus S4. So the total distance is going to be 1440 for S1 plus 1200 for S2 plus 3360 for S3, and for S4 is 720 meters. Okay, so the total distance will be 6720 meters. Question 2.3 is asking us to find the average speed travel for the entire motion. 3. The average speed travel for the entire motion. We know that average speed is equal to the total distance traveled divided by the total time taken. So the total distance traveled is 6,720 meters divided by the total time taken is 160 seconds. If we do that division, we have 42 meters per second as the average speed. Question 2.4 is asking us to find the total distance traveled during the first minute of the motion. So if we should ask ourselves, where is the first minute of motion attained? That is 60 seconds exactly. So the question wants us to find the total distance traveled after 60 seconds. That is to say, the first distance traveled and the second distance traveled during the two phases of motion. Question 4. The distance traveled for the first minute, that is for the first 60 seconds of the motion. If we go back to the diagram, we said that is going to be S1 plus S2 because exactly at 60 seconds, the motion has covered two phases. That is going to be S1 plus S2. And we calculated S1 as 1440 and S2 as 1200. So therefore we can say the distance traveled after 60 seconds is equal to S1 plus S2. S1 is 1440 meters plus S2 is 1200 meters. If you do that calculation, you get 2,640 meters. Question B5 is asking us to find the average speed during the same time interval as 4 above. So that is during the first 60 seconds. So we want to find the average speed now. 5. The average speed travel for the first minute of the motion. We know that the average speed will be equal to the distance traveled divided by the time taken. So the distance traveled for the first 60 seconds or 1 minute, that is 2,640 meters. So that will be divided by 60 seconds. And when you do that math, you get 44 meters per second as the answer. And finally, question B6 is asking us the retardation that brought the car to rest. So we will consider the velocity time graph for this answer. If we analyze this velocity time graph, the car starts to decelerate to rest from here and it reaches at this point. Okay, so which means this is the initial velocity corresponding to 48 meters per second, and this point is where it attains the final velocity corresponding to 0 meters per second. That is, the initial velocity is 48 meters per second, the final velocity is 0 meters per second, and the time interval there is 30 seconds. Okay. 6. The retardation that brought the car to rest. We said that the initial velocity will be 48 meters per second. The final velocity will be 0 meters per second, and the time is 30 seconds. But since we are referring to these events and they correspond with the fourth phase of the motion, so we can say V4, U4, T4. Okay, now using V is equal to U plus AT, we can say V4 is equal to U4 plus A4 multiplied by T4. We can say V4 minus U4 is equal to A4 T4. To make A4 the subject of the formula, we divide both sides by T4. That is, this will cancel this. So it means A4 is equal to V4 minus U4 divided by T4. V4 is 0 meters per second minus U4 is 48 divided by the time there is 30 seconds. So that is minus 48 divided by 30, and therefore V4 is equal to minus 1.6 meters per second squared. Okay, so that is the final answer of this question. That is your velocity time graph problem. It is very important to always make sure that you get everything accurately, okay? Because one of the answer will affect the other answer. So it is paramount, especially if you are calculating the distances. You can always confirm whether your distance is correct or wrong by using the equation of motion. S is equal to half U plus V multiplied by T. So for example, if I want to know the distance that is traveled for the first phase of the motion, that is S1, I know that the initial velocity is 0, the final velocity is 72, and the time interval is 40. So if I insert those values into this equation, I should have an answer that is the same as 1440 meters. Let's try to do that and see. So that is S is equal to half into the initial velocity for the first phase of the motion is 0 plus the final velocity is 72 multiplied by the time is 40. So that is going to be half 72 times 40, and that will be 1440 meters. Again, using the same formula, S is equal to half U plus V multiplied by T. For the second phase of the motion, the initial velocity is 72 and the final velocity is 48. Okay, so let's try to see if that works. S2 is equal to half U plus V multiplied by the time. And what was the time there for S2? The time there was 20 seconds. That is the time interval. So let's try to substitute the values that we have. That is going to be half. The initial velocity is 72 plus the final velocity is 48 multiplied by the time is 20, and you are supposed to have an answer of 1200 meters. So this formula can always serve as a guide for you to know whether you get the answer right or wrong. That is all for today. Thank you very much for watching this video. If this is the first time of visiting this channel, please like our videos, subscribe to the channel, and you can share the videos to your friends.